Welcome to all the professionals. Welcome to the regular. Sorry. Yeah, please go ahead. So please record this session, Lakshmi. So today we are going to have a session on smoke detector testing or a functional testing standards and use of solo and testify. So I'm Dominic, your host for this informative session. Maintenance of smoke sensor paramount importance and ensuring the reliability or functionality of smoke sensor is critical aspect to prevent fire. So end of the session, we'll have question answer. I would request my guest here to post your Q&A question answer at the bottom of the icon you have Q&A. You can post a question, avoid putting question on the chat box. And thank you for joining today. And I would like to introduce Paul Gittins. Unfortunately, his video has an issue, so he'll be on voice. So you will have an opportunity to see him through his video, which he'll be playing. And Paul now is currently positioned in London and he is in Britain. So he'll be talking to us from, I don't know what's the time, Paul, there? What's the time, Paul?
The time is 10:30 in the morning.
10:30 in the morning, and it's good afternoon in India. So Paul has about 10 years of experience in the fire industry, and prior to fire industry, he was also Microsoft certified trainer. So in his current role, Paul supports our worldwide customer base with product support and training, and work closely with detector manufacturers and industry trade associations. A regular speaker at industry events, Paul can also be found on YouTube channel as the presenter of our popular channel called Toolbox Talks. I repeat, Toolbox Talks. So if you're whenever you want to learn more, so please visit his popular channel called Toolbox Talks. So we are so grateful to have Paul with so much experience and wonderful speaker. So we will have begin with Parul, then Paul comes in, and with me we also have Parul Verma, who is the business development manager for India. She has over 20 years of experience in the fire industry in India. She worked in all areas of business, whether it is development, operations, sales, marketing, team management, project management, and brand management. In India, Parul has built solid network of consultant architects and influencers. She travels length and breadth of the country, and she's been trying her best to influence the fire authorities and try to demonstrate how to do a functional test of the smoke detector, not just the maintenance of detector. So with this, I would like to invite Parul to give your opening remarks, your experience. What do you think India is going, towards? Whether are we going towards functional test? Are we still with our, call agarbattis and jute still? Okay, over to Parul.
Thank you, Dominic. Good evening and welcome everybody to this webinar, which is the second in the series of 3 webinars. So we're going to have a third one, wherein the dates will be shared with you all shortly. And like Dominic said, this session is with Paul Gatens, who's an expert with detector testers with so many years of experience, and he's a technical sales support specialist in detector testers. He's got a whole lot of knowledge on this topic of functional testing, which is the very important part of safety when you're installing a fire alarm system. Functional testing is of prime importance, and I would like to let you all know that Paul, like already Dominic said, he has a YouTube channel wherein you can always go back and listen to his various videos which talks at length about functional testing and the types of testing which are there, which are prevalent when it comes to detector testers. We have so many brands like Solo and Testifier, And so today I would like to ask Paul, I would like to tell Paul to take over from here, and not because I'm not too well to speak more today. And I would like to tell Paul to speak about functional testing and our products, Solo and Testifier, based on that.
Thank you very much, Parul, and thank you, Dominic. Very kind introduction. Apologies that my video isn't working, my video feed isn't working. All I can tell you is I'm a lot more handsome than that photo that you're seeing in front of you at the moment. Yes, well, let's make a start. So let's share my screen, and then we can get going from there. So hopefully you can all see the opening slide that's actually come up there. So this is series 2, as Dominic's explained, finding the right solution. It's all about going to be focusing on functional testing. Let's move on and have a look at what we've got in store for us. Okay, so the first section, which is going to be the main section, which is all about understanding the basics of functional testing, and we'll be looking into that. We've got correct use of correct and compliant use of aerosols, because aerosols are still the main tool that's used in functional testing. We then can have a look at the aerosol range, the canister range that we have available. Move on to Solo. Finally finish off and talk a little bit about the electronic testers that we have in our range. So that's what we have in front of us. So just as a short recap of what we covered on the last section, one of the slides we talked about the various different test methods that were actually available out there. We have the electronic or button test, which is prevalent in certain markets and with certain products. And the issue that we discussed is that this doesn't necessarily give you a very high level of confidence, because it's only testing the electronics. It doesn't actually test the installation. Has the installation actually been successful? And thankfully for us, it's not compliant with many national and international standards that cover commercial fire detection systems. So that's electronic or button testing. No testing is a big threat, and again, because of ignorance or the lack of understanding or appreciation, or sometimes it's just down to cost cutting. There are a huge amount of detectors out there that are just not tested, and one of the things that we should be aware of is that detectors that are not tested frequently are the ones that will be relied upon in a fire. That's often the actual case. And I think there was one example over here in the UK where we had a fire, one of the big fire stations in London. It was underneath a staircase, and the detector had not been tested. The area that we're going to be focusing on for the remainder of this presentation is all to do with functional testing. And in particular, we've got to look at functional tests using aerosol canisters. And there's a difference there between handheld aerosol canisters and dispensers. And we'll be covering what those differences actually are. And we've also got a small section to talk about functional testing using the new technology that's been available for a number of years. This is using electronic testers, such as available in the Testifier and the Solo 365. And one of the things I think you'll see is that although aerosols are predominantly the main way of testing fire detectors, smoke detectors around the world, increasingly they have got their issues that we all need to make sure we're trained up and we know how to deal with. And the one thing that technology often brings us is technology gives us that opportunity to overcome those issues, and in particular the issues that relate to the misuse of aerosols and some of the other aspects of aerosol canisters. Because one of the things we've got to wake up to is that aerosol canisters, as far as testing smoke detectors, are 1990s technology. They've been around for a long, long time now. They're very effective and they're still the main thing to be used, but we just need to make sure we understand everything there is to do about aerosol canisters. One other area which we're going to touch upon very, very, very briefly, and this is very much at the forefront of technology at the moment. It's one thing to move away from aerosols and to electronic testers to do your tests, but one of the things that is desperately required within our market is transparency. The building owners need to have transparency to see exactly what detectors have been tested and what haven't been tested. And this is where we've just about launched our new XTR2 Testifier, the latest range, which literally just come out just recently. Here in the UK, and that not only does that do a functional test, but it creates an audit trail. So it picks up the information from the detector that's been tested to create proof of what actually has been tested. So it gives transparency to the building owner. And I think going forward, this is going to be absolutely key, because this is going to enable to drive out the cowboys, the people that are cutting the corners and not doing the jobs properly. We've only got a small amount about that later on, but we'll cover that. One other aspect which we covered on the last session was all to do with sensitivity testing. I haven't got time to cover that today, and we will actually put that in the last of the series tests. But sensitivity testing is different to functional testing. And this is where you're doing a smoke obscuration test. So you're measuring the level of smoke within the device. Now, this is a requirement for those that follow the American, the Canadian, or the Australian standards. And as we discussed in the last presentation, India is using detectors not only that come from Europe, which are governed by the EN standards, but also coming from the UL or NFPA 72 standard, which is the American standard. So you've kind of got detectors there, and there is some interest, I know, within India about doing, sensitivity testing, which does give you a more precise test than what you actually get with a functional test. But as I say, we've not got time today to dig any deeper into that one. So I just wanted to recap on that. So that's just for ease. What I've done here is I've just gone back to British standards, and a lot of standards, as we said, a lot of national and international standards derive from British standards. And I just really wanted to take a few little clauses here. So first one is what actually is a functional test, and British Standards clause 45.4 defines it quite nicely. It says tests should enable elements of combustion can travel unhindered from the protected room into the chamber and cause an activation. And that's absolutely key. And this is, the functional test is at this moment around the world is looked upon as being the best way to get the highest level of confidence, and that be for testing smoke detectors, heat, or carbon monoxide, or any combination of those. And you're proving that the firelight phenomenon can travel into the chamber and cause an activation. So that's what is covered there by clause 45.4. And it's also in the Indian standards as well, in slightly different words. 45.4 note 13, and again, this is what we were just saying a few minutes ago. The use of a test magnet or test button, it just doesn't satisfy the requirements when you're talking about commercial fire detectors. So it makes it really clear in British standards, it is not compliant at all with that. One of the other things as well, which we will touch upon briefly, because technology is moving on in all sorts of areas, and one of the areas is to do with detection. And what we're seeing is more and more multi-sensors that are coming to the market now. And these are fire detectors that usually employ a smoke sensor and a heat sensor, but sometimes can also include a carbon monoxide sensor or any combination of those. And 45.4J talks about the testing of multi-sensors. And again, it's common sense, really. It says, each sensor on which a fire detection signal depends, e.g. smoke, heat, or carbon monoxide, they should be physically tested either individually, one at a time, or together. And they can only be tested all together if you're working on the newer fire detection systems. And some of the newer fire detection systems will give separate channel notification. And by that, what we mean is that the heat sensor, when it goes off, you will get notification on the fire panel to say the heat sensor's gone. When the smoke channel is actually activated, it says the smoke channel is actually activated. This tends to be some of the closed protocol systems are actually out there, and some of the newer open protocol systems are coming out there. For example, Apollo have launched a new system in the last few years, the Dimension, and with their core communication, they can actually identify the difference between the different channels. I should say that most multi-sensors out there are legacy multi-sensors. They've been around for 10, 15 years, and they don't give separate channel notification, in which case the only compliant way to test them is to test each sensor separately. So you test the smoke first, or then you test the heat separately. So you test each one separately, and you get that indication that they've actually activated. But one of the things you've got to be aware of when you're testing multi-sensors is if you do test them individually like that, that may be compliant, but it's going to take you a lot longer to test them, because the whole point of a multi-sensor is to push back against false alarms. That's the whole idea of them. That's why they're becoming popular, and being installed. And what that basically means is that a multi-sensor that just sees smoke will take longer to go off. And if it sees smoke and heat, it will go up faster. And that has implications when you're actually doing your test and maintenance as well. So let's have a look at functional tests in a bit more detail. And in particular, let's start off by looking at the smoke evaporation. So what we're talking about here is the evaporation of test smoke. And it doesn't matter if you're using an electronic tester or you're using an aerosol canister to generate that smoke. There is an optimum temperature range here. And I know a number of you are, we will have to work with this particular range. The optimum range for testing smoke detectors is between 15 and 25 degrees. That's not to say you can't test them outside of that range, but you've got to be aware of what the limitations actually are. And the reason for this is that the test smoke is designed to evaporate at that particular in that particular range. And what happens is that as the temperature drops and goes below 15 degrees C, you will get a slower test smoke evaporation. It takes longer to evaporate. This has implications, and this has implications which can basically end up wasting time, because any lingering smoke around a detector can cause a reactivation of the detector. And in particular, this is an issue for conventional detectors. Now, again, I think we touched upon this on the last session, where we talked about the difference between conventional and addressable detectors. Many addressable detectors have the ability to automatically reset. So when the engineer carries out a test, the sensor is actually reset. But with a conventional detector, in most situations, you have to go back to the panel. Now, if the smoke is lingering around the chamber, you could go down to the panel, press the reset, go back to the detector, only to find the lingering smoke has gone back in to cause an activation. So you have to go back down to the panel again. So low ambient temperature is quite a big issue, particularly when you're using aerosol canisters, and particularly when you're testing conventional detectors. As the temperature, the ambient temperature rises, the test smoke can evaporate quicker. And this can actually mean a slower or non-activation of a detector. It can also lead to an over-application of the test smoke, again, if you're using aerosol canisters. And this is one of the actual key bits that you've got to be aware of. So higher temperatures, like between 25 and 30 degrees, this can be a problem. And of course, one of the things we've just been talking about is multi-sensors. And really what we've got with multi-sensors, and it's also a feature that is coming into some smoke detectors, is that we've got a process going on at the moment where the balancing of the fire detection sensitivity is being readdressed. Over about a 20-year period here in the UK, we've seen a reduction in the number of fires and fatalities. But the downside of it is that at the same time, we've seen an increase in false alarms. And what we're trying to do at the moment is to readdress that balance. We want to make sure that fire detection systems go off in a timely manner to make sure people escape and there's no fatalities, and that services can get there to contain the fire. But at the same time, we don't want them to be too sensitive that they're reacting to fire-like phenomena and causing false alarms. And that is a big problem around the world. And that's the main reason why multi-sensors are actually coming along. Now, what that's leading to is the integrating time. The average time to alarm is getting longer. And as the average time to alarm gets longer, it means if you're testing smoke detectors or detectors with longer integration rates, you've got to be more patient, and you've got more chance of problems starting to occur and more chance of wasted time. And this is one of the issues you've got. And in particular, if you're using aerosol canisters and you have got higher ambient temperatures, you will end up using more fluid from an aerosol canister. So one of the big things we've got to try to avoid, and it doesn't matter, what system you're using, is an over application of test smoke because that is what happens. The maintenance engineer in certain situations, particularly at the higher ambient temperatures, will apply more smoke to try to get that activation. And that means that the cost per test goes up. It means the chance of misusing it goes up. And there are a number of factors that actually relate to that. So, which can, in fact, actually end up in the worst case scenario if the person the engineer is using the product, they're not using a dispenser, they're using one of our aerosols designed for use in the dispenser, and they're using it by hand. That can shorten the detector life, and it can also lead to more time being spent at the detector. Okay, so we spoke a little bit here about a phenomenon called nuisance re-alarms, and we really just need to dig a little bit deeper into this to make sure we fully understand what is a nuisance re-alarm. This is where the fire detection system has been disabled from connection to the alarm receiving center. The engineer's on site and the engineer's carrying out the actual tests. And one of the problems that it can occur is the reactivation of a smoke detector after a test due to that lingering test smoke that we spoke about. And this does lead to more time on site, and it's a delay because of the delayed detector reset time. And what we've learned from the market is that this can be a significant issue when testing conventional detectors, particularly again with aerosol canisters. It's not a problem, with electronic products, and I'll explain more why. And it's not just about the temperature. There are other factors here as well that could also contribute. So we've got that low ambient temperature, which we said when you get below 15 degrees. You've also got a big rise in the amount of optical detectors that are now installed. They are the main type of fire detector or smoke sensing chamber that's actually used. And one of the issues that optical detectors have had to deal with is that they have to have some form of gauze or mesh around the outside of the chamber to keep insects out, because insects getting into an optical chamber will cause a false alarm. That's all well and good, and most manufacturers over a 20-year period have actually gone and implemented that. There's still a few out there that don't have that gauze. But the side effect is that if a optical detector has that gauze, it will hold the test smoke in, and that can contribute to the reaction of a fire detector. We said earlier about longer integrating periods. This is also becoming a contributing factor. So the longer time to alarm means that you end up with more smoke in the chamber and around the chamber and more possibility of reactivation. And of course, all of these factors lead to the engineer over applying the aerosol, particularly from canisters. This is the actual key bit. And it's all to do with, aerosol canisters are the main way of testing detectors, actually, smoke detectors and multi-sensors actually out there. But because of these factors that I've just actually covered, if you are using aerosol canister, you have to be more skilled now than ever before to get the best out of the system, to be as efficient as you possibly can in the time you're actually testing the detectors. Also to make sure you're not misusing them, so you could actually be prematurely aging the detectors and needing replacement actually sooner. So careful use of aerosol canisters can minimize nuisance-free alarms. That's the best they can do. But if you're looking to completely eliminate the problem, this again is where technology comes to our help. And in particular with what we call the clear mode. And all of our new electronic testers, the 365, the original Testifier, the XTR2, and even our fixed tester, the Scorpion, they all include a clear mode. And what does the clear mode do? It removes any lingering smoke from inside the chamber. And this is why you can eliminate it and not necessarily, and that can actually save you a lot of time. So let's just have a look at a video. Hopefully this is all going to work fine. So let's have a look. Nuisance-free alarms occur when the smoke detector under test reactivates due to lingering or excessive smoke still in the chamber. Sometimes this can mean an extra few minutes per detector, other times it can last half an hour or even more. Nuisance-free alarms are more likely to be caused when testing with a smoke aerosol canister, particularly if used by hand, increasing the test time per detector, which soon adds up over the whole site. We'll explore why this is and what can be done about it later on. Not all fire detection systems are the same. Some systems also reset after a test, whereas others require the engineer to carry out a reset from the fire panel. In extreme cases, multiple resets may be required before the smoke detector chamber finally clears and the engineer can move on to test the next detector. Here are 6 factors that impact how quickly the smoke in a detector chamber clears. Number 1, some smoke detectors have gauzes to prevent insects entering the chamber and causing false activation. The downside of this gauze is the fine mesh can also keep the test smoke in the chamber for longer, causing the detector to reactivate. Number 2, lower ambient temperatures, that's below 15 degrees C, can mean that the test smoke is slower to evaporate, which means it can linger in and around the detector chamber for longer and can cause reactivation. Optimum aerosol canister temperature range is between 15 and 25 degrees C. Number 3, areas of slow or no air movement, such as domes or small spaces, can mean that the smoke stays within the chamber longer, also causing reactivation. Number 4, over-application of test smoke by the operator. As detector activation times have been increasing to counteract false alarms, there is more of a possibility of the user over-applying the test smoke from an aerosol canister. Number 5, aerosol smoke canisters from detector testers include canisters specifically designed for either use by hand or within a dispenser. It's important to note that the Solo aerosols are optimized for use in the Solo 330 dispenser. They're not designed for use by hand. Use in this way wastes smoke, contaminates the detector, and can lead to nuisance-free alarms. And finally, number 6, if you require a handheld smoke test solution, then we have Smoke Saver with its unique design, which prevents the use too close to the detector, which eliminates both the risk of contamination and nuisance-free alarms. So how can we minimize the impact of nuisance-free alarms? Reading the instructions on the side of the canister really does help, so make sure you do that. Be aware of detector integrating times. Be patient. The newer designs have much longer times to alarm. Use less aerosol smoke. Be frugal with it. Also, be aware of the temperature impact. Canister temperature has an impact on the performance. So now you know how to minimize the effect of nuisance-free alarms. But what about if you want to completely eliminate the problem? This is where you need to look to the capsule or cartridge-based solutions that control the smoke release and include a clear air feature that removes any lingering smoke from the detector chamber and eliminates that wasted time caused by nuisance-free alarms. Okay, that's really helpful, and hopefully that's reinforced what we've actually just been covering. And I know you guys do like stories as well, and I've got a nice little story for you here. I caught up with one of our customers, a long-term customer, a while back, and originally he was a Testifier user using the product you see on the screen there, and he had changed jobs. He'd gone to another company, and he'd unfortunately given up his Testifier and gone back to using a Solo 330. And I just caught him just as he finished a job, and he'd been testing the fire detection system in a crematorium. And he was explaining a story to me, and he said, "You'll like this one." He said, "I know the answer." He said, "I just want to tell you this story." He said, "I got given this job to test the fire detection system at the crematorium." And he said, "I got strict instructions to get in there early and to make sure I'm out before 9 o'clock, because 9 o'clock, the first hearse will be coming down the drive, and everybody will actually be coming in there." And he said, "The last detector I tested was in the dome, in the crematorium. It was high up. It was a conventional detector. Because it was early in the morning, the temperature was actually lower." He said, "That detector took an hour to reset." He took an hour on it. And he said, "Of course, I know the answer." He said, "If I had my Testifier," he said, "I would have been gone and done in 2 minutes. But I had to waste an hour because of the fact I didn't have a way of testing it." And it was that low temperature. It was a detector which had a gauze around it, and and a dome is also another issue here because you've got a limited amount of air movement. So again, just emphasizes how technology has come along to improve things. So let's go and have a look a bit more about correct and compliant use of aerosols. So let's first of all understand about how aerosols work. The aerosol canisters are pressurized containers, and inside that container, they contain two things. They contain the product, which is the formula that we've made to test the detectors, and that for that product is a fluid that sits in the bottom of the aerosol canister, and then there's a propellant, a gas that sits on top of it. And when you press the nozzle on top, the gas then forces the product out through a tiny hole, and that through that tiny hole, that is actually how the mist, the aerosol is actually made into fire-like phenomena to actually test detectors. Again, the size of the nozzle and the pressure is all being adjusted to make sure that the particle sizes are between 0.01 micron and 10 microns, because as you can see on the little chart we've actually got there, fire or particles from a fire can, vary in size quite dramatically. And one of the key challenges that we've got with all of our test products is to make sure that the particle size, covers that range of actual products there. So what we need to understand is what happens to an aerosol canister outside of these ranges. When you're working outside of that range, you've got two temperatures to be aware of. One of them we've spoken about already is the ambient temperature, and the other is the canister temperature. As the temperature increases, because the aerosol canisters are pressurized containers, the increase in pressure in temperature leads to an increase in pressure. That increase in pressure then leads to less tests per canister, and it leads to quicker smoke evaporation as well. And it also means that the particle sizes are changed slightly, so they're not that optimum size. And this can then lead on to issues that relate to activating the actual detector. So that's with the higher temperature. At the lower temperature, pressure is reduced in the canister, and the smoke takes longer to evaporate. Again, the particles emitted are not the optimum size, and this again, in the worst case scenario, can lead to the detector not actually activating. One of the things you've got control over is you've got some control over the aerosol canister's temperature. You don't tend to have much in the way of control over the ambient temperature. Maybe you can put the air conditioning on, maybe you can, warm up the place or cool it down accordingly. But in most cases, you don't have that ability. You don't have that luxury to do it. But when it comes to the canister, you've got control of it. It's the tool that you're actually using. And one of the things that you can, it's worth knowing about, is that you can compensate for these changes or these extremes in temperature by either warming or cooling the canister. And by warming it, for example, if you're like we are here in the UK at the moment, we've got, cool nights, well below 10 degrees. And, what do most of the engineers do? They leave their canisters with their test equipment in their cars and vans overnight. And when they turn up at job in the morning, those cans are going to be cold. So to get the optimum out of them, the best thing to do is to move them to the footwell in the front of the vehicle. So as they're driving to the job, the warmth from the car heater just warms them up nice and gently. Or they could put them in their pocket, so they just warm them through in their pocket. And the inverse is when things get a little bit warmer, you might have to turn to taking a canister and running it underneath a cooler tap just to cool it down a little bit, not too much, but that's the compensation that we can actually do. So let's just finish off this section by looking at a little chart and how the electronic products and how they compare to the canister-based products. And looking at the bottom of the chart here, we can see we have two ranges of products that we're going to be diving into. We've got our non-flammable aerosols, which are the A10 and A10S, and then we've got our flammable aerosols, which I'll talk a bit about, the A5 and the Smoke Saber. And you'll notice that the working range of the non-flammable aerosols is a little bit wider. It has that ability to work in the extremes a little bit better than the flammable aerosols. But what happens is as that temperature drops down, that's when you start to have a few little problems that start to occur. And you can get to the stage when you get well below 10 degrees where it could be the case if you've got a long integrating period, you might not actually set the detector off. The reverse is also true. As the temperature gets higher, you'll also find the same. You'll get the ability to actually set the detector off if it's a slower activating detector. Sorry, a faster activating detector. But if it's a slower activating detector like a multi-sensor and you're just testing the smoke chamber, you may get to the situation where you can't actually activate it. We should also point out that because aerosols are pressurized goods, they're classified as dangerous goods. And the one reason for this is that, as it says on the side of any aerosol canister, it says do not expose them to greater than 50 degrees C because they will expand and they can explode and rupture. And it's quite shocking the amount of power a single aerosol canister can actually have. So it's absolutely key, not just with our aerosols, all aerosols, that you make sure that they are not exposed to greater than 50 degrees C. And even here in the UK, where at maximum we see like 30 degrees as the highest temperature, occasionally we will have problems. And the problems usually occur always in the same case. And this is where the engineer has left an aerosol canister on display in their vehicle and left the vehicle in direct sunlight. Outside, it might be 30 degrees. Inside, it will be well above 50 degrees inside the vehicle because of the greenhouse effect. And when they go, the aerosol canisters can explode and they can take the windscreen out. So please be aware of that. Now, if we look at the top section of this graph, what we actually see here is with Testifier, 365, and Scorpion, which all have this clear mode. What you find is as the ambient temperature goes down, all it basically means is that you need to make sure you use the clearing mode more. As the temperature goes up, there is less need to actually use it. And there is a bit of a skill here, just being aware of what the ambient temperature is and how much do you use. Is it 5 or 10 seconds? And again, it's slightly different between the different products. But again, this eliminates that nuisance reactivation problem that you can actually see when you're testing conventional detectors. So we started talking about the aerosol ranges. Let's just talk a little bit more about this and why have we got two types of aerosols for use within our dispensers. We've got Solo A10, which is a special non-flammable aerosol canister, and we have Solo A5, and we also have the handheld Smoke Saber, and those products use a flammable propellant. Now, going back in time, back to 2018, a lot of countries around the world were getting quite concerned about the environmental implications of aerosol canisters. And the number of the propellants that were used at that particular time were known to be causing problems with the ozone layer and causing problems contributing towards global warming. So in 2018, Detector testers, as a manufacturer, responsible manufacturer, we got told that we had to change the propellants that we actually use. So this saw the demise of the old A3, A4, a number of other products. And we know we had to come up with a non-flammable aerosols. Now, non-flammable aerosols are pretty special and a little bit rare. We've had to have a very special propellant made up for our Solo A10. And that means that although it's non-flammable, because it's specialized, it's limited actually use, it is a more expensive product. But it does also have an improved level of performance. As we saw on that graph, it will work across a wider temperature range. Now, in situations where flammability isn't a problem, you can use the aerosols that we use that use hydrocarbons. And hydrocarbons are a mixture of butane and propane. And this is what you'll find in any high street aerosol canister that you actually purchase from any of the actual shops. So this is a very common propellant that's used within aerosols, but it does have that one drawback that it is a flammable propellant. Now, there are many situations where you can test in offices and various different buildings, and there isn't any risks involved in actually using flammable propellants. But there will be situations where, either the service company wants to be very risk averse or the client actually wants to be very risk averse. And in which case, this is why you have a choice. So if you're using dispenser aerosols and you want non-flammable, you're looking at the A10. And if you want flammable aerosols, you're looking at A5. And A5 has got the same formula inside of it and the same setup as our handheld smoke saver. And we'll talk a little bit about the differences between this later on. So yeah, this was a big change that came into effect because of the F-gas regulations. And this is a worldwide regulations, which is pretty much adopted by most countries. And it's likely to continue to restrict aerosol canisters in the future. At the moment, there is no plans for regulations to tighten further, but it's always possible. I think it's always likely as well. So we'll talk a little bit about that in a bit. So aerosol canister safety, as we said, high temperatures, there is a risk of explosion. These are classified as dangerous goods, so you need to be very careful where you store them, how you transport them. For example, aerosol canisters cannot be transported through the normal postal service. You have to use special couriers to transport them around. There are always going to be issues that related to aerosol canisters, not necessarily our aerosol canisters, all aerosol canisters, because all aerosol canisters are classified as dangerous goods. And it's really important to make sure you read those instructions. And really, the couple of things you need to watch out for is high temperature, as you said, do not expose to greater than 50 degrees because there's a risk of explosion. And then the other aspect as well is in particular to do with the flammable aerosols, because if an aerosol canister is punctured in some way, the flammable gas will be released. Now, if it's in the open air, that's not a problem. But if it's in a confined space and there's a source of ignition, that's going to cause a flashover explosion. And sure enough, there have been cases again around the world where this has actually happened. I did read about one story here in the UK, and it wasn't with our products, it was an air freshener. And a lady pulled up in a car park and she turned the ignition off on her car, pushed the seat back to relax. And as she pushed the seat back, she crushed an aerosol canister, releasing the flammable propellant. And it just so happens at the same time she lit a cigarette. So there was a massive explosion on that. And that's just from a single aerosol. I don't want to scare you at all, but it's just important. And it's not just about aerosols, it's all aerosols. And increasingly, the health and safety aspects of aerosols, people are becoming more and more risk averse about it. The other factors we mentioned, shipping constraints, storage, you need to make sure you're careful on storage. I mean, a few years ago, I do remember seeing a maintenance engineer open up in the back of his van, and he had like about 10 boxes of aerosol canisters. Again, many of the service companies now are saying, well, you can only really carry one box of them around at any one time. We also have material safety data sheet available on our website. So if you do have any concerns about the content of them, and certainly material safety data sheets are constantly being updated. And this is not because we're changing our products. This is all because the rules and regulations around aerosol canisters continue to actually to tighten. And it's a full-time job for us to keep those safety data sheets up to date. If I go back 17 years ago when I joined, the amount of downloads we had of the data sheets was probably in the hundreds. It's in the tens of thousands now because people are concerned about what's actually in the products. And one of the questions you may be asking, or you may actually be asked yourself, is it safe for me to actually to use this product? Now, I've had that question come to me several times. I'm not a doctor. All I can say is that if you're of good health and you're using the products as instructed, there isn't actually a problem. If you've got asthma, if you're pregnant or you've got some other sort of disability, take the safety data sheet along to your doctor, let a professional person make that decision whether it's actually safe for you to actually to use. So that's absolutely key. And I think this is one of the reasons why safety data sheets are, particularly popular at the moment. The future is going to be more legislation around aerosols. As I said earlier, there is no expectation for aerosols in any time in the future to be discontinued by detector testers or by worldwide legislation. But the expectation is it's going to continue to tighten. So that's the question that many people ask, will they be discontinued? And I've made that quite clear. Currently, no regulation plans or plans by detector testers to discontinue aerosols. And if we're completely honest here, these are the main tools that are actually used in the world. However, regulations will continue to tighten, particularly around health and safety, around the environment. I mean, there's now looking at the VOCs that are emitted from actual aerosols. You've got the unique formula identifier, which is basically to identify if aerosols have any kind of toxic product. That's a new standard that's actually come in. We've also got the situation detectors are coming smarter, which can mean longer test times, which means more important for training for those who are actually using aerosol canisters. And it can also mean that in certain instances, there are some detectors out there where you cannot test them with aerosols at all. Okay, I think I've got another little video for you. Stop me talking.
31st of December 2017, the new F-gas 2 regulation had an impact on our range of aerosol canisters. Aerosol canisters that use propellants that were outlawed by the F-gas regulations, we are no longer allowed to manufacture. This included A3 and A7, amongst a couple of others. However, you as a user or reseller, if you have stocks of A3, A7, check it or can smoke, you're allowed to carry on selling and using them until all stocks are actually used up. The restriction on it is on us as a manufacturer. For those that wish to continue to use non-flammable aerosols, the old A3 has now been replaced by A10, available in two sizes. A10S is 250 and there's an A10 in a 150 canister size. Both are non-flammable and a direct replacement for the old Solo A3. In situations where use of a flammable aerosol isn't an issue, there is Solo A5 as an alternative, which is a more cost-effective solution, which gives a lower cost per test. Detector Testers dedicates a lot of time and resources to the testing of our products, and we work very closely with the detector manufacturers to make sure that our aerosol canisters are approved for use on ionisation and optical detectors when used with the Solo 330 dispenser.
Okay, I think that puts that point across. So let's have a look at the aerosol range then. As we said, we've got two divisions here. We've got handheld aerosols and we've got dispenser aerosols. So handheld, quick and easy, ideal testing detectors in tight spaces or anywhere within arm's length. Historically, a lot of thought was actually given to the fact that with the older handheld aerosols, it was looked upon as being, well, that's the bottom end of the market. That's what people are really going to do as an absolute minimum. But with the advent of our smoke saver product, this is a product that pretty much everybody has, even those who actually got our more sophisticated testifiers, 365s and XDR2, they will more likely still have a smoke saver in hand because there's always going to be those detectors in those hard to reach locations, those difficult to access locations where smoke saver, can actually be a useful thing. If you think about it from the point of view of your toolbox, you look in your toolbox, you might have several hammers. You'll have a club hammer, a pin hammer, a claw hammer. There's different hammers for different purposes, and the same thing is true when it comes to actually to testers. And that's really why smoke saver in particular is a great product for everybody to actually to have there. We also have carbon monoxide testing. We've got our C6, which is handheld aerosol, which is a bit more specialized. That's particularly to do with testing CO life safety, not for fire, that handheld aerosol. When it comes to dispensers, the key bit you've got to get here is that you must use compliant aerosols with this. You must use those white aerosols with the blue tops. That's the A10, A10S, and the actual A5. They've been particularly formulated for use within the dispenser. And when you use it with a dispenser, that means you can reach all the way up to 9 meters, subject to a risk assessment. You can also take out the smoke out of the Solo 330, and you can put a can of carbon monoxide. This is C-free for testing CO fire detectors and some CO life safety as well. Please note that 9 meters maximum height is subject to a risk assessment. So there's our dispenser aerosol range, the A10 and the A5, and also the carbon monoxide C-free. And again, just to make this clear, if you see anybody using those by hand, they're not using it in a compliant way. And unfortunately, this has been happening quite a bit within our industry. And if I'm completely honest, that's been great for our profits, but it's not good for the detectors. Handheld aerosols, we've got Smoke Saver, which is available in a 150 and a 100. And there we have the Solo C6, which is a very specialized product, as I say, for CO life safety. And CO life safety is an evolving market. And I'm sure that in the future, we're all going to see and hear more and more about this. Currently fire detection systems just detect firelight phenomena, and they don't necessarily detect levels of carbon monoxide that could be toxic or hazard to the individuals. But we are now starting to see that break into the market, and we're starting to see that it's now in the American standards. Cheeky have now got a fire detector out there, which has got smoke, heat, and CO, and the CO can be configured for fire or life safety. They've got different levels, sensitivity levels that they can actually set up. And I'm expecting this just to continue to expand. So we may well be hearing more and more about CO life safety as opposed to CO fire. Dispensing canisters in use, only use the recommended aerosols, as we've said, so A10, A10 or A5. Dispenser test cup comes into contact with the ceiling. The test cup membrane creates a seal around the smoke detector or CO detector under test. Make sure that membrane is fitted and it's in good order. It's not split, because if it's not doing its job, the test smoke is going to escape. The CO is going to escape. And this also goes for the heat testers as well. With our Solo dispensers, you need to give a 0.5 second to 1 second burst. So you push up onto the ceiling to activate the release of the actual aerosol. Please be aware, again, as we said earlier, about those higher temperatures. The higher temperature will mean that there'll be a more dispersion rate, it'll be a higher dispersion rate. So you have to be even more frugal and careful when you're working over and above 25 degrees. On the side of the aerosol canisters, it says repeat application every 10 seconds up to a maximum of 5 applications. I would put a caveat to that to say, again, if you know the detectors you're testing and they've got longer integrating periods, such as the multi-sensors, don't go as far as 5 applications. You just need to be patient, because some of these detectors are 40 seconds all the way up to 2 minutes to activate. And of course, if you're using an aerosol and you're not trained about use of the aerosol, you're not trained about the detectors you're actually testing, there's that temptation to over apply the smoke, and that over application of smoke could lead to nuisance re-alarms if they're conventional, and it could also lead to shortening the detector's life. So please think about that detector integrating period. That's absolutely key, that you need to know that. Bear in mind that ambient temperature bit we said, as the temperature goes up, higher internal pressure, less test temperature. The other thing you should be aware of when it comes to aerosols is that aerosol canisters are sold by weight. They're sold by volume, not by weight. So if you was to pick up a can of Solo A10S and a can of A5, and they were brand new, you would notice the difference in the weight between them, because they have different densities to that particular product. So it's important to be aware of that. Okay, let's have a look at Solo testers. The dispenser we've been talking about is a Solo 330, but it's also worth mentioning there is also a bigger test cup version, the 332. Now, the 332 was originally designed to test the American UL detectors, where some of them are a little bit bigger. So again, if you've got these UL detectors installed, you're going to be better off going to a 332 than a 330. But in most places around the world, the Solo 330 is the dispenser that everybody actually goes to. The test cups are not interchangeable, so you go one or the other. you choose the one that's appropriate. And as we said before, these dispensers can be used with our solo high access poles that gives you access up to 9 meters. And the whole point of a dispenser is to try to restrict the potential possibilities of misuse. But again, in the wrong hands and somebody who's not been trained, it's still possible that they could actually, if they tried hard enough, they could actually misuse it. But again, if you understand about detector integrating periods, you know you've actually got to be patient. Then you just need to apply the smoke and then actually wait. So 330 and 332 are for commercial detectors. We do see an element in certain parts around the world of residential alarms, which are bigger integrated devices. They tend to be tested by the bigger test cup, the 332. Okay, let's just see. I've got a full video, I think. Let's have a look.
The Solo 330 and 332 are used with the compatible Solo smoke and carbon monoxide aerosols that are used to carry out functional testing of commercial fire detectors and residential fire and life safety alarms. So which one are you going to use, a Solo 330 or a Solo 332? The Solo 330 over the years has become the industry standard for testing commercial fire detectors. The test cup has a diameter of up to 100 millimeters, which means it will accommodate commercial fire detectors that are available on the market. The Solo 332, as you can see, has a larger test cup of 172 millimeters across, which is ideal for accommodating residential fire and life safety alarms.
Okay, just to emphasize on that last video there, the larger test cup, it was designed for the UL detectors, the American detectors, and in the UK we don't have any of the UL detectors, and that's why that device is used for the residential detectors. So correct use. So do not use A5, A10, A10S by hand. That is the most important thing there, only for use in a dispenser. The nozzle spray pattern will lead to incorrect particle size over application. Probably the way you're thinking about it, somebody explained this to us, it's a bit like using a sawn-off shotgun. You're going to put far too much smoke and again, into that particular detector. And that's the important thing, to make sure you use those aerosols in that dispenser, because that could potentially lead to damage to the detector under test, and it's not compliant in any way. The time to alarm, for testing smoke detectors can be anywhere between 5 seconds and 2 minutes. You do need to be patient, certainly with some of the newer, more sophisticated detectors that have got longer integrating periods, and particularly those multi-sensors. Consider the need for a risk assessment, a method statement before testing. If you're working in a public area, for example, and you've got a tester which you're waving above other people's heads, think about what could actually go wrong if you actually lost control of it. We're going to have a quick look at heat detectors, and the key bit here is that there are a number of there's 2 standards out there that cover heat detectors. You've got the European standards, which is what we follow here in the UK, and you in India also have a degree of these EN545 detectors. But you also have the NFPA or UL heat detectors, and they just have different methods of classification that they actually have here. The key bit to be aware of here is that there are a whole array of different heat detectors out there, but we're talking about mainly the point type detectors that you will find installed in a typical type of commercial building. And these have different thresholds at which they actually go off. Typically, in most situations, a standard sort of office is going to be 57 degrees. If it's something where there's going to be a little bit more ambient heat, then it might be an 80 degrees. And then if you're working in like commercial kitchens or industrial areas where there is a high degree of heat, that's when you go to the higher activation detectors. These are the ones that have an activation point above 90 degrees. Now, it's again important to be aware of what heat detectors you're actually testing and what environment you're actually working in, because some of our testers will not test those higher activation detectors. So let's have a look at the Solo range. We've got 2 heat testers in the Solo range. We've got the battery-powered Solo 460, which is a very popular tester, and particularly because it's battery powered, it hasn't got any mains training lead there. But the one thing that you need to be aware of is that that tester only goes up to 90 degrees, so it won't test those high heat detectors out there. It doesn't have enough heat output. Whereas the mains powered 423 and 424, I mean, it's just different voltage levels that you actually have there according to where you're actually working. That will go over 100 degrees. So that will test those higher activating detectors. But the downside of it is that it does have that trailing lead. Another factor between these two testers you should be aware of, with the mains tester, you've got unlimited amount of power almost there. So the heat wave that comes up from underneath is extremely wide, and it basically makes testing a heat detectors really simple, really quick, and really effective. When it comes to the battery tester, you've got a pencil thin beam of hot air that is which is actually goes across the test cup, and the idea is to go through the detector chamber and then hit upon the thermistor within the actual chamber. And the reason for this is because we've only got a battery there, so, a 7-volt battery that is actually connected to the actual tester. One of the things, again, this is where knowledge comes about and experience, is that heat detectors design is changing. Not only have you got different profile sizes, you've got different positions of the thermistor. Historically, legacy, they were all centrally mounted, but increasingly now they're offset thermistors or dual offset thermistors. And when you're using the battery powered tester, it does mean that some instances you have to think about how you're testing that particular detector. And one of the key bits that many people have done is rotating the tester around the detector under test, because that disperses that pencil thin beam of hot air across a wider area, and it can mean you get much quicker test times. So the need for new technology. We've mentioned about aerosols. We're talking about the technology which is the most common, and it's actually out there in many countries around the world. And for many years now, detector testers has been aware that ultimately, things do have to move on. And that's what we've been working on for a number of years. We've been working on alternatives to aerosol canisters. And what we found is capsules and cartridges. That's what we've been working towards. And why have we got capsules and cartridges? Because they are not classified as dangerous goods. They are not pressurized items. They mimic, if you like, inkjet printer cartridges. They work in a very similar way to that. So there's no flammable products. They're much easier to use, much safer to ship around. And also the electronic products that go with it can be more controlled in the release of the smoke. So there isn't any possibility of misuse. So where we are lacking skills and detectors are getting more sophisticated, it's not an issue for the electronic products. It's an issue for the canisters. And this is why it's really important for anybody using aerosol canisters to make sure they're properly trained. Because with the electronic products, you're going to get far more consistent results, because it's not temperature or engineer skill dependent. We've also got the situation where detector design is changing. Technology is making detectors less prone to false alarms, and in some cases harder to test with aerosol canisters. Again, this is something that we've overcome, with the new electronic testers. It's a much cleaner test that it carries out. So it's a far better user experience. Any of you that have used our dispensers for a period of time will know that the dispenser can accumulate lots of dirt and muck in there and will regularly need actually wiping out. With the electronic testers, it's a better user experience, and it also leads to the detectors lasting longer. Now, this is quite an interesting thing that we've been picking up from the market increasingly over the last few years. And one of the things that has been explained to us several times by people that use our electronic products is that the best feature they like is the clear function. But when you ask them which is the best feature they don't talk about it as being a clear function. They talk about it as being a clean function. They're of the opinion that the blast of cool air that actually goes through the detector after a smoke test is actually helping to clean it. And certainly they, in their own eyes, have seen evidence that the detectors are lasting much longer. And I would say that although that could be potentially true, I think it's more likely that the problem is that people are using aerosol canisters perhaps are not using them in a compliant way. They're misusing the aerosols, which potentially could mean shorter detector life. So that clear function is often seen as a clean function. It's a bit pushing it a bit to say that, but in their eyes, they can see the detectors are lasting longer. Faster test times. Obviously, everybody wants the efficiency now, and we've got longer integrating periods, so that's not necessarily helping us out. But if we can eliminate those nuisance-free alarms, which we can do with all the electronic testers, that can dramatically save some time. Obviously, the environmental issue. This is increasingly a thing that many manufacturers have to look at. And of course, our capsules and cartridges are much easier to actually use, to track, to even down to the actual disposal of them. So they're a much more environmentally friendly test solution. So just to finish up the last slide here, these are the electronic testers that we have in our product range, and I'm not going to go in any further at this particular stage, but we've got in the middle there, We've got the Solo 365. That's a smoke only tester. It has an adapter that enables you to actually test ASD systems. And it really is a great upgrade from those of using the Solo dispensers to move across to that. If you want to test an all-in-one tester, you've got the original to Testify 1000 and 2000 range, which has been proven to be very popular, especially as multi-sensors have become more popular. And now, which it's not yet released in India, but it's starting to come out around the world, and that's the Testifier XTR2. And it has the same functionality as the original Testifier, but it's capturing what has actually been tested. It's got that proof of compliance actually built into it. So thank you very much for your time. Hopefully I've done that in exactly 1 hour. So apologies, I did one a little bit earlier than that. Any questions?
Perfect. Yeah, perfect timing, Paul. 503, you took exact 1 hour. Wonderful. Very professionally presented. I would request the audience who would like to talk to Paul or Parul. You can raise the hand. I could see two of them as raise their hand. Nalla Masa. So Nalla Masa Ravindra. So if you're there, I'm allowing to talk. You can talk to Paul. And you can unmute and talk. I'm also asking Dharika, if you are there listening to me, you can unmute and ask your question to Parul or Paul.
Yep, don't be shy.
Okay. Anyway, we'll take a few questions. So those who have any doubts, so please put your questions in the Q&A box. And I will take up the few questions there now. Arya is asking, which is the ideal detector tester among all types of detectors? Does it say the ideal detector for tester among all types of detector tester? It could be, yeah.
Okay, well, it does depend. It depends on what your budget is, what type of detectors you're actually testing. We've covered, the aerosol-based products, which are still extremely popular product out there for testing and what most people actually work with. In my experience, what I find is people start to consider some of the things that we've actually covered to do with aerosol canisters, and they start looking at that Solo 365 being that mid-range product. And the 365 is a great upgrade for those moving on. So they keep their heat testers separately, and they get away from the aerosol canisters and they go to the actual 365. They then have the added advantage that the 365 has got some really nice features in it. It's got like a built-in torch. So when you go into an area or you're testing in an area where there is no light or you don't know where the light switch is, the torch helps you actually find that detector. In addition, it also has the ability for removing the test cup, and you can put an ASD adapter on there. So if you're testing ASD adapter, ASD systems, aspirated systems, then the 365 is really good on that particular point. I then find that people start to look at the 365 and they start saying, yeah, that's great. It's really good. It's got all these nice little sort of features. But then if I look a little bit, spend a little bit more out, I can go to the Testify range. And with the Testify range, the big advantage you've got there is you've got one tester. You've got one tester you attach to the top of the pole, and that is what you're carrying around with you all day. And the scenario that is often relayed to me is that an engineer will turn up on site and he might have solo testers, separate smoke and heat testers. And of course, the majority of the detectors he will be testing will be smoke. So he'll be going around with his what he calls the smoke pole, the smoke tester on the end of the pole, and he's testing smoke detector after smoke detector. Then he will come across a heat detector. And then the thought goes back to his mind. He's thinking, I've got to go back to the van. I've got to go back to the fire panel to get that heat detector. So he's losing all that time walking around the site to actually pick it up because he doesn't want to have to carry the two side by side. When you've got Testifier, you've got that one product in your hand, and whatever devices you actually come across, you've always got the right tester to actually test the detector. So from the point of view of efficiency, it takes a lot to actually to beat Testifier.
Well, good. There's a question from Nina. How many times in a year a detector should be tested?
Okay, but this is something we covered on our last seminar, but I'm happy to actually to go back through this again. Generally speaking, it's usually at least once a year that the detectors should actually be tested. It can be more than that. And frequently, this is actually driven by any form of risk assessments that's taken out, because what are the risks and hazards within that building? Are there sleeping accommodation above the commercial area? Are there processes going on? Is there dirt and contamination and optical detectors? These are all things that can actually lead to a more frequent testing that goes on. And it is quite common here in the UK that 2 tests a year on a slightly bigger site, just because it also means you've got to visit the site twice just to do your inspection. So if you're going to visit it twice, why not just break the testing down so you're actually testing twice a year? And in some cases that can also be 4 times a year.
4 times a year. Wow. So minimum 1 year, and depends on the occupants, the position of the detector, so you can go up to 4 times a year, which is almost once in 3 months.
Yeah.
So again, Nina has another question. Is there any potential hazard that occurs during testing?
Is there any potential hazards during testing? Yes. I mean, there's always in hazards what we're actually doing, and this is why that any competent engineer must be trained on how to carry out their work in a safe manner. One of the training courses that we've actually got on our website, which is a self-study course, is safe use of our solo height access poles. If you think about it, you're working with our and you can be working up to heights of 9 meters. Now, not everybody is of the same strength and same experience. So it's really important to make sure that you've gone through the training course, you understand what all the actual issues actually are, and that you are carrying out your own risk assessment when you turn up. You're taking out a risk assessment, and the risk assessment will dictate what precautions you have to take, what PPE you have to actually to wear. For example, we don't specify what PPE to wear, but we do specify you should do a risk assessment, because the risk assessment will then lead to what PPE you wear. And this could mean that if you're using a height, one of our longer poles, you might have gloves on. You might have eye protection because you're looking up. You might disturb some dirt that might fall into your eye. If you're working on a building site, you'll have to have a high-vis jacket on, a hard hat on, toe protectors on. These are the sorts of steps you're doing. It's all about that risk assessment. Our industry is very much central around carrying out risk assessment. That's not only a risk assessment of the building and the site that the detection is actually protecting, but it's also a risk assessment of you when you're carrying out your maintenance. You've got to make sure you carry it out in a safe manner. And increasingly, what we're finding here in the UK and across Europe now is that building owners in particular, they have a responsibility, even to a maintenance engineer. If a maintenance engineer comes onto site, and if they start doing things in a dangerous way, it's their responsibility. So you'll start to get building owners saying to the engineer, surely is there a safer way to test that detector than to use that 9-meter pole? And there could be. For example, Scorpion. We haven't spent much time talking about Scorpion, but Scorpion is our fixed tester, and that can alleviate the whole need for using height access poles.
That's fine. Now the last question is from Maria. What is the maintenance cost of a tester? So there is, I'm sure, there are, the maintenance that involve in maintaining the tester also. Do you have, how often that need to be serviced?
I think the best bet there is for me to pass it over to Parul for that one. Parul, can you answer that one? What's test? Because I can give prices for UK, but you're more in control of the prices for within India.
Yeah, right now, I think as far as the aerosols are concerned, that's the only the consumable. So you have to buy the cans. That's the only maintenance cost, which is repeated, like depending on the number of detectors you have and the number of tests you do. Based on that, you have to have that number of cans to be replaced whenever you do a test. And when it comes to the electronic testing equipment like the Solo 365 or the Testifier, the cost would again be only the capsules, the smoke capsules, which are used there in that. So otherwise, as such, there's no maintenance cost for this tester. And maybe Arya, you can send me a mail if you want a quotation for the testers and the consumables. We will send it across to you with all the details.
Probably.
Fine. Thank you, Parul. And with that, I think there's one more question. Just what is the meaning? Yeah, that's finished. So we have done with the question answer, Paul. I think the people on holiday mode, December, though we have quality attendance, we have decent participants. Almost we are in the last week of December, so everybody, as you are going on a vacation, so a lot of holidays, and the climate is changing. People are unwell. Parul, I can see how tired you are, how stressful you are today. Sorry to keep you holding.
No, no,
And,
no, no, no.
it's
It's always a
such a wonderful knowledge session. I'm sure
yes.
as we keep
All
doing
sessions
this.
are very, very not, yeah, they're very informative, and I wouldn't miss it for anything. So that now when I'm out in the market promoting DT, I can use all the tips which he's given us, wherein, we can further answer many more questions to the customers and users, everybody. So I would like to thank Paul for this wonderful session.
You're
Thank you
welcome.
so much, Parul. Those who have further more questions, please write to Parul. Her mail ID is there in the chat box, and she will
Yes.
take from Paul. And anybody who's interested in the product or a demonstration at your the location, there are distributors spread across India. So Parul can connect you to the distributor, nearest distributor. I welcome everyone to be interacting with Parul. So finally, thank you so much, Paul. Wonderful presentation with such a senior, individual as you are, and your toolbox talk in the YouTube is very informative. And I'm sure those who have understood will surely go and visit. So, last final word from Paul.
Thank you very much, Dominic and Parul. Thank you for the time and this possibility to talk to your market and everybody out there that's listening. I hope you've actually found this of use and value. And as Dominic's actually said, we've got plenty of other resources that you can check into as well in the YouTube channel, and we've also got a lot of information on our website as well. So hopefully, have a good holiday period, everybody, and I look forward to catching up with you again in the new year.
Yeah,
Yes.
we come back again for the third series very soon. We'll declare the date shortly. And till then, I wish everyone a happy Christmas and a wonderful New Year. And look
Yeah.
forward to a prosperous New Year.